How do we judge how steep something is? Well, when we compare ramps, we need to look at how tall the ramp is versus how wide it is. We call this the rise and the run. When you look at the gray and the brown ramp here, a lot of people are going to jump to the conclusion that the brown ramp is the steepest. It's number one. But they would be mistaken because it's not how big the ramp is, but how tall compared to how wide. So here you will notice that the brown ramp's rise is less than its run. Whereas with the gray ramp, the rise is more than its run, or it's larger than its run. So when we look at how steep it is, we compare the rise to the run. The gray ramp has a bigger number over a smaller number, which overall will result in a larger number or a steeper ramp. So when we look at the steepness of this green ramp, in this case, to me it looks more like the rise and the run are about the same. When you divide numbers are about the same, so 1 over 1 or 3 over 3 or 7 out of 7 or 100 over 100, this all results in a rate of change or steepness of about 1. Rate of change is another word we have for how steep something is. Okay, so what does this mean when we're looking at a line? So our rate of change or our steepness is rise divided by run. So what I'm going to do is I'm going to start by picking 2 points. I'm going to pick this point and this other nice point up here that's got some nice whole numbers to work with. And I'm going to draw a ramp that goes from the one point I picked across and the other point down to meet in a ramp. Okay, so I drew a nice red ramp there. And here the rise, it's going from 0 up to 6. So it's rising up 6 units, and its run is 2. So the rise over the run is 6 over 2. So that's what we call my rate of change. But of course, 6 over 2, we're not going to leave that as 6 over 2. We know we can reduce that. 6 divided by 2 is 3, or 3 over 1 if we want to leave it as a fraction. Okay, so could I have picked a different ramp? Well, I could have drawn this smaller ramp here, but what you'll notice is it really is the same ramp. It's just a different piece of that ramp. So now my rise is 3 and my run is 1. 3 over 1 gives me the same steepness or the same rate of change. It's positive 3 because as you go from left to right along the x-axis, your ramp is climbing, it's going up. All right, here is an example of a ramp with a negative rate of change. You'll notice now that as we move from left to right, the line is falling. So I'm going to pick 2 points like I did before, and I'm going to connect them with a ramp. What you'll notice this time, instead of rising, it's falling from 0 down to -2. So from 0 down to -2. So our fall is 2, and our run going this way is 2. So our rate of change is our rise, which in this case is actually a fall. Sometimes I call it a fall instead. So -2 over the run of 2. But -2 divided by 2, that's just -1, or -1 over 1. So if I picked a smaller ramp instead, if I picked these 2 points here and I connected them with a ramp, I've got 1 unit over and 1 unit down. -1 over 1 is the same as -2 over 2, or just -1. So it's the same ramp, just a smaller piece of it. Okay, so finally, what would the rate of change for a horizontal line be? So I'm going to pick 2 points again. Remember, rate of change or steepness is just your rise. Well, in this case, it does not rise at all as you travel left to right. So 0 over this piece of the horizontal line that I picked is 1 unit for the run. 0 over anything, doesn't matter which or how long the piece of the ramp that you picked, is going to still just be 0.